coffee, and a 30-minute short break. So our theme for today's conversation is sacrificing health and productivity for energy. Today, I'm excited to introduce our special guest, which is Ty Newell. Ty is the co-founder of Build Equinox and manufacturer of CERV Smart Ventilation Technologies. He is a professor emeritus of mechanical engineering at the University of Illinois. Ty has worked in renewable energy, energy and efficiency, sustainable living technologies, HVACR, and building sciences for over 40 years. Ty lives in a zero-plus energy home in Urbana Illinois with rainwater harvesting and 2 first-gen EVs. Build Equinox is located in a 4,500 square foot Morton building that is net zero with 8.5 kW of solar PV. Some general guidelines before I turn it over. The option to click in the grid view in the right-hand corner to change your setting if you want to see more individual callers. The chat function is below. Feel free to add in any kind of information that you would like to below. Please be respectful of others and allowing others to join in the conversation, but be mindful of not jumping over anyone speaking. Feel free to talk without being called upon, but if you do have something to say and you don't want to interrupt, go ahead and use one of those little reactions below. I'll try to make sure that I engage with you the next opportunity. And just try making sure that you keep yourself muted unless speaking to avoid any background noise. And without further ado, Ty.
Hey, well, thank you very much. And I appreciate this opportunity to talk with you. And so I've kept these very brief, but there's a lot of background behind the slides I'm going to show you. And I'll send a couple of very recent presentations to Emily and Brandon that they can post and share with you for those interested in more information. But as Brandon was alluding to, I'm like a broken record. You know, we need to figure out how to live, in the words of Aldo Leopold, on a piece of land without spoiling it. Simple thing to say, extremely difficult to do. And so that's guided my whole career. And a lot of my friends, as well as my wife, will tell you I'm like a broken record. She's got to hear this stuff every day of her life. So it's nice to have a different audience, and perhaps that'll relieve her a little bit of, me having to speak to her on these topics so much. In any case, but she's a true believer too. And we have a wonderful solar powered house, and it didn't cost any more than our neighbors. And as Brandon said, driving 2 electric cars, I pinch myself every day that all the tools and technologies are here and they're economical. And so now there's still a lot of battles to be fought, but now everything's here for what we need, and it's just a matter of getting that integrated into the way we live, the way we work. So this, but the topic for this is really about air quality, and really what ASHRAE calls acceptable, what Passive House calls adequate, is just not. It is not acceptable nor adequate. And we've been saying this for years. The data is in the literature from the studies. Donald Milton at the University of Maryland and previously at Harvard have found that if we double today's ventilation standards, we would reduce sick days by 40%. And that's how much the flu, seasonal flu and colds would be reduced. We also would have drastically reduced the severity and impact of COVID while waiting for vaccines. And we get increased productivity. Again, another study by Harvard School of Public Health, along with Lawrence Berkeley National Labs, that going from today's standard ventilation rates, which at least 20% of the populace is not satisfied with, that when you ask them, are you satisfied with the air quality in your building or in your house? 20% of the population is not satisfied with it. That we know today's ventilation standards are deficient, and that if we double it, we're going to improve productivity and we're going to reduce sick days in cost-effective manners relative to the energy required to operate our buildings. these are just pictures of CO2, and the one takeaway is how important CO2 is as a measurement to determine the air quality in a building. And let me just point out a couple of them. This one down here, 751 ppm of CO2, 684 ppm of CO2 in big box stores. If you take a CO2 sensor like this one, you can get them for a couple $100 now, or this one. And so the room I'm in is in not too bad of a level, 679. This one, which is a wireless one, and so it just chirps a message, in this case to a ventilator. Here's one that a colleague of mine in electrical engineering has been developing that it's a wearable. And so wherever you're walking, you can determine air quality and VOCs. And then we'll see if this works. I've got my Alexa account. She probably heard that. But Alexa, what's my CO2?
Site CO2 is 566.
So that's the CO2 in my house. And so the technology is here and it's getting less and less expensive. And what does that mean? Well, at today's ventilation rates, which nominally are maybe about 20 cubic feet per minute per person or less, but that would result in about 1,200 parts per million of carbon dioxide. And here I am sitting in our test chamber here at our business. And if I'm just sitting there working on the computer, it takes maybe about 8-10 minutes. It's a walk-in cooler, but it doesn't have fresh air blowing in. So it's pretty well sealed. And as it continues to build up to unacceptable levels, but not smelly levels, just ones where you'd say the CO2 isn't so great. And then I leave the chamber and it starts to decay. Out of that decay, there's a lot of information. For example, I can find the infiltration rate, like doing a blower door, but what we call a tracer gas test. And that shows that I had about 1.5 CFM of infiltration of air moving in and out of the chamber. That's about 4 times my breathing rate, which is showing you that just at nominal sedentary conditions, my breathing rate, this isn't enough to keep the air fresh. And if I'm exercising here, lifting a weight, a 10-pound weight from the floor to a table and putting it back, then I climb within 2 minutes from what was really good air quality to, because I self-polluted myself in that chamber, within 2 minutes hitting this level. But when you control at about 800 parts per million, you've doubled the airflow rate. You've gone from 20 CFM to 40 CFM of fresh air. And a lot of people would throw their hands up and say, we couldn't afford that. Our utility bills will be sky high. We must save energy, not people. And so the message that we've been putting out over the last several years, not just with COVID, but in general, is that we need to improve our indoor environment. Our buildings are making us stupid, sick, and tired. And the cost for Illinois with, say, mid-January average conditions, 22 Fahrenheit, and wanting to keep comfortable at 70, 72 indoors, if I go from 20 cubic feet per minute up to 40 cubic feet per minute of fresh air, the difference in utility costs without any energy recovery is 1.5 cents per hour per person. And I think we're worth at least 1.5 cents per hour more, whether at work or at home or at school. Likewise, today's building standards, which are in this range, we're talking about 20% of the populace being dissatisfied as CO2 levels go up to this range, and CO2 and dissatisfaction are coupled. Now there's other things, our own VO, our own VOCs we're emitting going up with CO2, and so that's adding into the dissatisfaction with air quality. But the dissatisfaction air quality is quite high, And there's surveys with like the Center for Build Environment from UC Berkeley showing with over 30,000 people scattered among over 200 buildings that less than 20% buildings are able to have only 20% dissatisfaction. And I think the big box stores in maintaining such a higher level of ventilation. So if you go in one and measure, I think you'll probably find it's about 700-800 ppm. And I haven't gotten to somebody at one of the big box stores to ask them that, but I'm pretty sure they know that this air quality dissatisfaction could be the difference between a customer going to their store or a different store. And I'll end on this one. This slide is pretty messy, but basically this is saying as you go from 20 CFM to 40, and then you add appropriate filters. So where today's filtration systems are typically MERV 8 to protect the heat exchangers when they should be MERV 13 to protect the people. This is where you get that 40% drop in sick days. And the value of that is about 5 cents per hour per person. So in the middle of January, no energy recovery, the utility costs about 1.5 cents per hour per person, sick day savings about 5 cents per hour. It's a no-brainer, it's cost effective. And when you add in the cognition data, which this figure shows from Harvard School of Public Health data, using that as the background for this computation, you're talking about a 50% per person per hour increase in productivity. But as I tell people, it's not necessarily that people are then working in a productive direction. They may just be getting a higher score in a video game, but their brain is functioning better when you do this improvement in fresh air and filtration. So I'll stop there, and I'll send more background material to Emily and Brandon for others to look at.
That's really great. I think super interesting facts that you just threw out there. We have some questions and comments coming in the chat. I think you kind of went over some of the financial obstacles to the higher ventilation, but is there anything you want to be able to expand upon that?
Yeah, let me say that as, so here's what typically happens, and I hope I'm not offending any facilities people, but generally, like a school administration or whoever's running a business, office manager, they'll throw it over to the facilities people. Facilities people will say, okay, yeah, we're running at ASHRAE 62.1 or whatever. That's not good enough, but of course, that's all they have to operate on. And then their budget, the utility budget, is separated from the human resources budget. We've got to somehow bring those two together because it's that combination where you can optimize. And that's what's not being done. And another thing that I'll send to you is something we're calling a COVID safe space and IAQ calculator, but a simple spreadsheet that the numbers in these things are derived from, but it helps people understand infection probability from COVID, which is now finally fading out, we hope, with continued vaccination. But then coupled with that are these calculations on air quality dissatisfaction, sick day reduction, and cognition productivity. And then a third worksheet that allows you to assess the energy impact and the utility cost impact on cooling and heating. And I'll mention that even though energy is very small relative to human value and improvement of our productivity, that energy can stand on its own. It is important to recover energy and to do that efficiently, but that 1.5 cents per hour per person of utility costs, you can just base that on some type of energy recovery system, maybe $10, $20 per CFM to install, a nice commercial size energy recovery and good air filtration system into a building.
So can we go back to that first slide that you had where it was the various different CO2 levels at in each building?
Yeah.
One of the questions that came up is, what is a healthy CO2 level?
Yeah, I just brought the chat up too. So I think 800 or less, and outside now is 400. It was 300 when I was born. And one of the frustrating things as we look in it's not a question that we'll get to 600 parts per million in the future. It's whether that's going to be 40 years or 60 years, well beyond my time. But if you want to hold, say, 800 parts per million inside of a building, and it's 600 parts per million CO2 outside, you're going to have to double from 40 up to 80 in the future. We're going to see additional ventilation costs, whether we can bring in enough fresh air to keep our brains functioning well, as we start seeing atmospheric levels go up to that level, or we have to start acting like a submarine and bring in some kind of active CO2 scrubbing machine that I don't really think is fresh air as what nature provides us, but I mean, we're getting into this area where to think maybe in a more futuristic manner, perhaps we're going to dumb ourselves down so we can't think our way out of this problem. The CO2 levels get too high. So 800 right now, and the reason for that is twofold. And this is pretty recent stuff. The Cognition productivity is since 2013 with some fundamental studies from Lawrence Berkeley National Lab, Harvard, Syracuse University, SUNY New York, really serious folks with excellent cognition tools. And that seemed to show the biggest gains were dropping down to about 800, and then it kind of tailed off, that then the brain is functioning pretty well at that level. And it's functioning well at 1200. Nothing you can notice that in degraded cognition. I mean, you don't feel dumber at 1200 than at 800, but when you go through these battery of tests on creativity and decision making and organizing information, you definitely see this drop off at that level. On the sick days, the studies done by Don Milton, who regularly is, and he truly is, the expert in airborne transmission of diseases. He's been working on it forever. And it really, down to 800, so 1200 to 800 is this big jump of 40% decrease in sick days. Now you can get sick elsewhere, so even if you're working in a healthy environment, in this store or restaurant or at home, you're just as likely to maybe have a very efficient flu and cold transmission with poor air quality. But 40% is equivalent to what the flu vaccine gets you to. Now, a further study by Milton where they looked at dropping down below 800 didn't show additional gains in decreasing sick days. And so both the cognition studies and the sick day studies seem to say, well, let's set the mark at about 800 for now. And then with today's sensors and wireless communication, I mean, there's no reason why every space doesn't have a CO2 sensor and why you can't ask Alexa or some other device what the CO2 or air quality is in that space. And so those things kind of lead to 800 is where we've been setting the mark for the last several years. And
do you think that with COVID, a lot of, I would say, businesses and commercial buildings have changed their parameters because of the need to make sure that they are ventilating fresher air because of the spread of viruses and diseases?
The awareness is there now, and hopefully, as we're now being told, if you're vaccinated, you can stop wearing masks, that our memory still keeps it in place to make these improvements. I see the one question on working with ASHRAE to increase it. And you know, and I'm a longtime ASHRAE member. I've been giving a number of these talks to the ASHRAE regional groups, and they're avid listeners. The problem within ASHRAE, and ASHRAE is a tremendous engineering society. I mean, it's critical to us operating buildings properly. I'm a long-term member, and as a young engineer, it was very important in my development. But when you get on some of these committees, industries are playing offense and defense. So for example, the natural gas industry, the last thing they want would be ventilation standards that would say, if you cook with gas, you should have to ventilate your house differently than if you have an all electric house. And you know, cooking with gas, it's not healthy. We've known this for decades. Jack Spengler's data from Harvard back in the 70s, we were seeing nitrogen oxides and sulfur oxides and other things that are asthma triggers just being spewed out of the burners of it. And I tell people, you know, if I had to choose between having a modern car idling in my living room or cooking with gas, I'd pick the car. I've got an oxygen sensor that's more completely burning that hydrocarbon, plus I've got a catalytic converter, and you know, and the burner on your stove doesn't. So my thought is that we've really got to do this outside through USGBC. We're longtime friends with the Passive House folks, and they've truly moved the marks for all of us in where houses and buildings can go in energy standards, and I think more of a grassroots operation to get people to just do this. We don't have to have anybody legislate it, and then I think an organization like ASHRAE, which is critical because then EPA's Indoor Air Plus, USGBC, Passive House, others align themselves with those standards, and so but I don't think we're going to get it done within the 62.1, 62.2 committee. There's a lot of great people on it, but I think they need to hear that people are just already doing it, and then they need to catch up.
So would you recommend an app or a device? I know you talked about the devices earlier, but you mentioned kind of Alexa using that. So is Alexa then connected to your devices that you have, and is there a specific app that we should use?
So yeah, in that case, without this being a commercial for the ventilation system that we make, something we call a CERV, but yeah, that is, and you'll see that in our most recent newsletter article coming out for May, that we just announced this voice control of the CERV unit through Alexa, and Google will be coming along and things like that. But here's the power that we see in a ventilation system. So, you know, we don't think of ourselves as a ventilator. We're working toward, we want healthy indoor environments. We want energy efficient environments. But with voice control, you know, maybe it's just going to be a novelty and fade, but something we call pre-ventilation. And a lot of the things that afflict us, whether a sinus attack, a migraine headache, a bout of depression, an asthma attack, an allergy, there's deterministic things. There's things that have happened, things I've eaten, things I've done, the amount of screen time, people I've interacted with, the pollen count outside, a whole variety of things that, you know, I can't count. And in some manner, all of this data that we can now assemble, big data and artificial intelligence, as much as it creeps you out, but, and like a baseball bat, it can be used for a lot of fun, or it can be used as a weapon. And so we think of these things as good things, but for sure you want to think of how can people use these for bad things? You know, we always need to be aware of that. But to what our way of thinking, if we can link, so my data is all online from our ventilation system in my house. If you go to our company website and you scroll down where it says take control, you'll see a live controller. You can go to the historical and look at CO2, VOCs, temperature, and all that. And I can now talk with Alexa to have Alexa change this or that, or tell me the status, wherever I am in the world. But just think of if I can say, you know, I didn't sleep very well last night, or my throat's a little scratchy, or I can feel, you know, like I'm going to get a migraine. I don't know why, or I'm getting stuffy, or my eyes are watering, you know, any mix of these things. And I just kind of a verbal diary of how I'm feeling. I'm feeling pretty good. I had a good sleep last night. And that data mixed with quantitative data on all these other things, biometrics from whatever I'm wearing, and that maybe we can start to see trends, and we can head off or mitigate whatever affliction that might be impending in a day or 2 days or 3 days. And maybe we can't eliminate it, but I think through my data and your data and other people's data, we can collectively figure out what makes us feel better and what makes us feel worse. And hopefully, just in an unintrusive, in a seamless, transparent manner, help us figure out what makes us feel better. And so that's what's driving us in, you know, in this area of healthy buildings. So I'm excited though with all the capabilities and the tools, and that we can get this into our homes. Really, the home is the forgotten environment. We've just relied on construction flaws to get air in it. And we need good quality construction, and then a smart way to ventilate. And I see there's a bunch of chats coming through, and I'm not keeping up with them. And so, yeah, that, you know, Bob's note on 10 CFM per person is right, that it kind of wanders around depending on building size and number of people. And affordable homes, smaller homes tend to pay a bigger penalty with ASHRAE 62.2. You know, a 2-bedroom, 1,000 square foot apartment or manufactured home, that they're going to have probably about 10 CFM per person in that, 2 bedrooms with 4 people. Yeah, and any organizations you're in contact with, and I'm more than happy to meet with them. And also, as far as school districts or teachers or administrations in schools, as they're preparing for next fall to reopen, while we hope that COVID is becoming a more distant memory, that I'm more than happy to work with individual groups with this COVID safe space calculator. It's really meant to be a communication tool so that teachers, PTA groups, administrators, facilities people, that here's a common piece of information they can all work around to see how face masks or vaccination levels or ventilation and filtration levels impact the infection probability, the chances that if you walk in a room and you're in there for 3 hours or 7 hours and there's an infectious person in, what your chances are of getting sick, plus more importantly, this parameter that I call the infection multiplier, but it's really what the epidemiologists call R0. It's the ratio of how many people are going to get infected if an infectious person walks in that space. And that multiplier has to be less than 1 in order for a disease to die out. And we've been bouncing around with levels of 1 to 3 to 5. One person making 5 people sick over their infectious period. And we're just now getting below 1 for a sustained period of time as you watch these infections drop. But that's a key parameter. Every building needs to get that number below 1 so this disease dies out. And of course, we've seen the benefits that flu and colds really do drop down with the isolation, improved ventilation, face masks, and that we've been wearing.
All right, we are at 10:31, which is 1 minute past our time limit for these coffee breaks. But I'm gonna, I want to thank Ty for joining us today. This is such an important topic, and even though I wish we didn't have to live through the pandemic that we just did, it has brought to light even more so how important indoor air quality is. So appreciate this discussion. And Ty, if you want to send us some follow-up, I'm happy to share this with the group that's here today. Just want to encourage everyone to keep an eye on our calendar, the USGBC-Missouri Gateway calendar. We have a wonderful summer series of coffee breaks coming up, focusing on green building certification, starting the 28th with Hannah Roth, who's here with us today. She'll be talking about her new book that she co-authored on the Green Building Materials Manual. So that'll be great to get us started. And we have a member social coming up on June 8th. Lots of other things on the calendar too, but just want to highlight those few things. And again, thank you so much, Ty, for being our guest today.
Thank you. I appreciate it.
Awesome. Everybody have a great Friday.
Can you share your website again?
Yes, I'll send that to information to Emily and Brandon as well.
Thank you.
Great. Thanks for joining us. Good to see folks.